Honestly.
Yeah, let's do the meta version. I love that.
Oh,
Did we already start recording?
how else will
Oh,
they get
damn.
boring content?
Okay, so we're in the frame.
Yes.
Mics sound good. So, who are
What's-
you, bro? What are we doing here?
I mean, that's a good question for sure. I mean, I'm Rahul. Uh Wait, I am Rahul.
You are Rahul.
Yeah, I'm Rahul. I've been hacking with electronics for a while. Do a lot of ML and like AI stuff on the side for fun. Um, and I've been looking at robotics for a while. It's just that it's been the amount of effort that requires what that is required to like build a robot is huge. Uh, when LeRobots as I saw like when I saw LeRobots SO-101, that was rather a game changer because I always looked at robotics as a bottom up approach. You start with figuring out the physics, you figure out how mechanics work and everything, and then you go on into building robots. SO-101 flipped it for me. It's like here's like the like a fully designed, super cheap robot arm. You figure out what you want to do with it, which is exactly what I wanted.
Yeah, like, so, okay. Hi, I'm Ashwin. I've not been hacking robots since forever, but that's like exactly the point why I think like I was like super inspired to like even start, right? Like it's this beautiful marriage between comp science, electronics, physics, and math, and it's like the most beautiful blend. And like as you said, like the whole idea was like you go bottom up, right? Like you figure it out from a controls and systems and dynamics point of view, and then you like start thinking about the hardware and stuff. But then like I love what like ReRobot put on their page, like this is the chat GPT moment for robotics, right? Like that's exactly what they said. And that's kind of like what got me also like looped into this thing. And it's been like the most awesome experiences, like programming something that moves gives so much more
Yes.
joy
Yes,
compared to like
yes.
coding a server that sits on some black dark room on the internet, right?
Exactly. And this is one thing one of my friends said. Amit, you might see
Uh-huh.
him on Twitter as well. He talks a lot about the fact that getting into like robotics and like even electronics, seeing stuff happen physically, the dopamine circuit in your brain flips versus like getting code to run. It's
Hitting
a
new
very different
thresholds.
experience. Yes.
Yeah.
Getting hardware to work is a very different experience, and you get a very different hype from compared to writing code.
Yep. Being a software dev has like almost walled me from this joy for so long, and I'm like so glad that I finally like gave this like a very serious shot, and I'm like not going back to the other world.
But sir, we have jobs.
Yeah, we have jobs. We have jobs, guys.
Yep.
Okay, so we participated in the LeRobot hack that happened on June 14th and 15th,
Yes.
2025.
Yes.
And we are team
Two arms, three eyes.
2Arm-3eyes, guys.
Yes. Two
So
arms, three eyes.
because we got two SO-101s and
Yes.
three cameras.
Yes. We decided that we didn't want one. One was too little. Two is the right amount.
Two is always better than one.
Yes. Two is always better than
Two is
one.
always better than one.
Yep.
Yep. So
The,
so we got the stuff from where did we get the stuff from?
we got it from Wow Robo, mainly because it's really, really hard to get servo motors in India. If I
Tough.
wanted to like order the VTech servo motors that we use on a leader and follower robot, it would take me 1 month.
Yeah,
Yeah,
it's like crazy.
because Alibaba takes a lot of time to ship, and Wow Robo is the only place who would ship it within a week.
Yep. And like we also scouted Indian options, right? Like we
Yep.
looked at WebShare and like a bunch of websites like Robu and like other stuff.
Yep.
None of them were like even gonna ship in time for us to even build anything.
Yep. Even those that would ship in time wouldn't have the right gear ratios. We only got the ones for the
Yeah.
follower, not for the leader. So we decided eh, we might as well take a chance on like Wow Robo.
Yep.
We weren't honestly too sure. I
Yeah.
was like, my $550 is down the drain.
Yep. But at least we got it on time and we built it. Yeah.
Yes.
Up top. Okay. Awesome. So once we got them, we like put this together. It was actually very fun assembling it, right? Like the
Yep.
parts just click in perfectly. Love the design, like
Yep.
very thoughtful, and like they have left like all the grooves for like putting the wires in, and
Yeah.
like
Yes.
everything's like very well designed.
It's a well thought design. It's just that when you 3D print stuff, you can't sort of ensure that it's 100% accurate. There'll be a few
Yeah,
things here and there because of which we had to sand in. So like maybe the grooves have to be sanded in. We
yeah,
had to sand in some of the area that is left so that your screws could go in, whatnot.
yeah. The motor driver mount, you had to like press that thing in like that was super
Yes.
tight.
Yes. So I mean, those are just kinks of
Yep.
using 3D printing parts.
Shout out to the amazing Chinese dude who has this super long video tutorial of how to put this
Yes.
thing together.
Yes. Thank you, Leo. Thank you.
We'll link it in the video. We'll link it in the video.
Yes. Yes.
Awesome. So
This is a
yeah,
YouTube video?
I don't know. If it goes on YouTube, it is.
It is.
Okay. So next, so we got the stuff, we put the things together, and what did we build? What did we end up building? I think like let's talk about what we ended up building.
What I wanted to do was make a sandwich maker or some type of like meal maker and like plug it into GPT, Claude, and have like a voice interfacing, maybe hang it over through MCP. But what ended up happening was we decided we would start with the most basic thing that we could solve for, which is take push the box and like scale it to a two-arm coordination deal.
Yep. Like we are always hungry for the record. So
Yes.
we wanted to like cook food, but then we ended up cooking boxes.
Yes. We
But
ended up moving
yeah, like
boxes.
I think the whole thought process is something like we want to reflect on, right? Like so we have two motors, like two arms, and
Mhm.
like we want to focus on coordination, and like you could make a sandwich with just one arm. I think somebody on the hack
Yeah.
also did. But we really wanted to demonstrate like some type of like collaboration between them, like one policy running both arms. And I think like the task we picked was the simplest version of that.
Yep. Um. Well, we wanted to do a lot more with
Yeah,
two-arm coordination.
always.
While it was the most simplest and like I believe it's the most simplest and like easiest way to demonstrate two arms collaborating.
Yep. I think it's like worth like telling the audience what the actual task is. Like, what did we do with the two arm
Yes,
coordination?
yes.
That what was the goal for the robot?
So the main goal with this task was we would have 4, 5, n number of boxes placed on the working area
Yep.
in random positions, and the goal was that the robot, the two arms would coordinate with each other to place them in a center square.
Yep.
So we highlighted a small area on the working area, with like 4 pieces of tape,
The
and
bounding box.
yes, like a bounding box, and we would want those 4 boxes or n number of boxes placed in that area. That is it.
Yep.
Very simple.
And the important thing is like the coordination part comes in when like one box is like not reachable by the other arm.
Yes.
So it's like if something is off to the extreme right, you
Yep.
would want the right arm to first pull it in place and the left arm can like place it properly.
Yep.
And that's something like we really wanted to highlight, like wanted the policy to learn.
Yes. Exactly. So I mean, another example of that would be both these arms have some form of restriction in range.
Yep.
So if you keep it slightly towards the behind of the arm, for instance, that arm won't be able to reach that box. So
Yep.
we wanted
Exactly.
another arm to help it get access to the box, and then the left arm, for instance, would put it in the right position.
Yep. There are a bunch of like dead spots where it does
Yes.
not reach, like right under the arm, like right at the base of the arm itself cannot reach. So you need another arm to pull it into the working area.
Yes.
Yep. But yeah, that's kind of what we built, right? Like, so
Yep.
we built a two-arm teleop record and policy which learns to position boxes
Yes.
in the center by coordinating.
One of the main challenges that we had with this was that when we got the arm set up, there wasn't a two-arm policy or a
Yep.
two-arm teleop, any of those things set up. So we had to sort of build our own like config for
Yep.
teleop recording and inference.
Yep. But like shout out to the LeRobot team. Like they shipped a really
Yes.
good API like
Yes.
just a few days before the hack.
Yep.
And that API like really helped like make it clean and easy to read and hack around the whole record and teleop
Yep.
and policy training part. So shout out to the LeRobot team.
Thank you.
Thank you. Thank you.
Yep.
Yeah.
Uh, so once we build that out, we actually wanted to extend it a bit more, because when you have a two row, I think when you have anything more than one robot arm, it's rather restrictive to not give it a global view to know
Yeah.
where like the other arms are, which is why we added the camera.
Yep. A global camera on top
Yes.
with like a top view. So,
Yes.
or else the only other alternative was like we had to somehow incentivize one arm to look at the other one
Yep.
always.
Yep.
And that kind of like takes away the actions it can do for coordination. So, having
Yep.
a global camera like is a really good like feature upgrade for us.
Yes. Yes. And it's really important that both the arms know where the other is.
Yes.
Otherwise, coordination would be extremely hard.
Extremely hard. Yeah.
I think it still might be possible with RL.
We will try that out. We
Yes.
should try that out. We'll
Yes.
remove the top one and we will try that out.
Yes. Yes, we will. We will. So that was one of the main challenges. The next one happened right after we collected a bunch of data, where we used the gripper.
At 1 a.m. on an ominous night.
Yep. When Ashwin went back home, I stayed up and I wanted to record a few more sessions so that we can have enough data to train our model. Turns out, training too frequently without breaks not only breaks human beings, also breaks robots. You cannot get machines to work for too long. You have to always monitor and make sure they're not overheating.
Yeah, man. Machines burn out faster than us. Wow.
Yes. It took about what, 10 sessions?
Yeah, we did like what the 12th episode died, right?
Yep,
So
the
we were
12th
like
episode died.
on an episode marathon and like we were at the 13th episode and like one of the arms just went bloop.
Yep. And it was the elbow one that broke.
Yeah, we popped the elbow.
Yep. It just golfer's elbow.
Yeah, we got the golf server. Damn it.
Yes. Well, it got so what happened was during the session, it just got stuck. The whole
Mm.
motor halted, but it halted to a specific position out of nowhere. I was scared. Um, I immediately flipped the power and unplugged all the USB-C cables, just to make sure we're not sending any write
Any more
information.
rights? Yeah.
Yeah, just avoiding all writes, avoiding any power to the motors, because I've had experience blowing up a bunch of like LEDs. Again, not at the same level as servos. I've burnt LEDs, a bunch of them.
Does it smell the same?
It smells worse.
It
Servers,
smells worse.
servers smell worse.
Of course.
Yep. Well, luckily we ordered another pair later.
Yeah, like we got, but then like let's talk about what we did during the hack because we burnt
Yes.
the elbow.
Yep. So during the hack, when we burned the elbow, the first thing I did was I removed everything, and then, uh,
We looked inside.
yeah, we looked inside in the morning, and we
Looked
decided to like,
perfectly fine, right?
yeah,
Like mechanically, it was pretty good. I did not like everything moved
yeah. All the gears are fine. There was right amount of grease there for sure.
for sure.
And when we tested the electronics, the write to the firmware is also working fine.
Yeah, that was the weird part. Like we thought we fried the chip, but then we could connect it to the debugging software and even run sweep, but then it just wouldn't like move the actuator. It would just like show that the torque is applied, but it wouldn't turn.
Exactly. And what we realized was that we removed the gears right after. After we removed the gears, we noticed that the core motor, which is part of the servo itself, was
Yeah,
not running.
yeah.
Well, at that point, it was either, oh, is it the electronic circuit that's like not giving it the signal or the power to run, or is it just um like something mechanically broken in the internally of that motor itself? So we decided it was not worth our time to fix it.
Not in the hack at least.
Yes, we were short of time already. We had like what, another five, not five,
14 hours, 12 hours.
not 14 hours either. We had like 8 hours left. We
Yeah,
had to figure out how to restrict the motor and collect new sort of training data because,
we can't do the same tasks anymore
yes,
because we
because,
blew it.
yes, we blew it and we recorded using the gripper a lot and
Yeah,
using all the elbow and stuff. So we had to figure out a way to move this restricted. So what me and Ashwin decided was we would sort of uh, firstly restrict the leader and the follower to not go beyond certain positions. So we changed the calibrations
yep.
min max. We looked at the offsets by plugging in the debugger and then set that as the offset.
Yep.
So it will not move more than
It can't
one
do more
degree.
than one encoding point.
Yeah, one
Yeah.
encoding point. So that helped us a lot
Yeah.
because even if we accidentally moved the leaderboards,
Nothing would
leader
happen.
arms, yeah, it would nothing will happen.
So basically we took the motor out of the elbow, swapped it with the one in the gripper,
Yep.
make the bicker static by changing the configs.
Yes.
And then once we got it static, we had, as Rahul said, like we had a lot of picking up and placing it stuff. Now
Yep.
we moved to like more of the push T kind of a thing where you like
Yes.
use the gripper to like just move the boxes around
Yep.
into the center area. So that was the
Yes.
new modified task we had to
Yes.
improvise in the hack.
Yep. That and we had to collect a bunch of training data just with that.
And we had to re-record the training data, of
Yes.
course.
Yes, we had to
But it
re-record.
was super fun, man. I love using the whole teleop record feature. It's like it's so like mentally rewarding.
Yes, it's mentally rewarding when all your motors are working.
I agree.
But when one of your motors are like burnt out and we swapped it into gripper, it would still overheat after
Yeah,
every 2 episodes. And these episodes are like what, 1 minute to
60
2 minutes
seconds
max. Yeah.
and 30 seconds of reset, I guess.
Yes. And then we had to like we couldn't run the 30-second reset. We had to do at least 1 to 2 minutes of
Yeah,
reset.
like I think the new protocol became we record 2 episodes,
Yep.
unplug everything, let it cool off, and
Yes.
then replug it, record 2 more episodes, and like kept doing that.
Yep. That is the only way we could collect enough data. And we still, I think, fell short.
Yeah, we
Uh
had like some 20 samples. We have 20 samples in our
yep.
training data.
The first thing that we wanted to do was we actually wanted to use a larger model to train, but then having seen others like get decent results, we decided we should actually use act,
Yeah.
like because everybody had decent results with act, we thought we'll
Yep.
just start off with act. But act took a while to train on our local GPUs.
Yeah, like
And yep.
yeah, so like it's worth mentioning like we tried training it for like 10K steps and like pulling the model and trying it out.
Yeah, that was
Not
bad.
that great. We would like now we know why the default is 100K steps and not 10K
Yes,
steps,
yes.
right? Like so it's really like worth running it through to the end, like 100K or more steps,
Yep.
and
And
worth getting a bigger GPU to train on.
yes, worth getting another bigger GPU for sure. But at the same time, when we pulled it out, the loss was like what, point 0.1
Yeah, even at like point 0.2 something loss, we were like not great.
in terms of machine learning. Like that is still a reasonable amount of
Yeah, that
loss.
is like still like above par at least.
I wouldn't say above par.
Okay,
It's
it's
like
par.
Nah, yeah, I
Or
think
okay, debatable. Moving on.
debatable. But then
Training to 100K is the trick, right? Like 10K steps does not cut it.
yep. So we decided we'll use small VLA.
We will use small VLA, but then we realized we don't have enough VRAM on a local GPU.
Yes, my GPU is a 1080 and it only has like 8 gigs of VRAM.
The model is 16 gigs, 12 or 16 gigs, right?
Yeah, it's around 12 or something gigs, 12, 16 gigs. It no, it is actually like 6 gigs and 7 gigs or something it would occupy in memory. But then the data set and everything,
Yeah.
it would push it
You
off.
need like at least 12 to 16 gigs of working memory, right?
Yep, I think 16 gigs of memory would have been enough to run it,
Yep.
like to train it. But that was not, we didn't have access to 16 gigs of memory, only 8. So we
Yep.
decided to use Google Colab.
Because I couldn't figure out in time how to use the $20 credits that Hugging Face gave us.
Yep.
But now I do.
Yes. Yes. Now you do. Now you
We
do.
will link the doc to that also somewhere. You will find it.
Yes. We decided to use Google Colab in the meantime.
Yeah, we are just like let's get the biggest thing we can and train this as fast as we
Yep.
can. We got A100s.
Yes, we got A100s
Sweet.
and trained it for 5 hours.
Yeah, all through 100K steps on small VLA.
Not 100K steps. We went to like 50K steps.
Yeah, 50K steps. Yeah, oh, small VLA was 50K steps.
Yes, we went to 50K steps on small VLA, and
Give us the
then
loss. Give us the loss.
the loss was 0.005.
Damn.
Now we are talking like proper ML loss. Like this is like you have a proper vision
No,
algorithm
no, guys,
loss.
it's not overfitting. No, it's not overfitting.
I think it's okay to slightly overfit on a environment that is constant.
Fair, fair.
Like you're not going to take this and use it elsewhere.
Yeah, it's pinned here.
Yep, it's pinned here. We have like some variety in lighting and everything. Pretty sure we could also do transforms on a video later if we need to.
Yeah,
But
there's a lot of experiments to be done there.
yep, lot of experiments to be
A
done
lot of
there.
feature
But
engineering.
still, I believe it was trained enough. It did
Yep.
not overfit.
Yep. Totally agree. And like that like really was like one thing, like just getting like bigger GPUs like just increases your iteration speed and like makes the whole process more fun. And like
Yep.
so we got the more, and we also like ran another 90K steps that was remaining on the act policy, but then unfortunately we
We
had to like, okay, initially we like talking about like training policies, right? Like one thing we screwed up the first time was when we started a run, we did not have good enough like intervals for saving the model
we
checkpoints.
had no save checkpoints. The
Our
save
save
frequency
checkpoint was at the end.
Our save checkpoint was at the end because somebody forgot that 100K steps is
Yeah,
the total number of steps.
I totally forgot about that, and I was like, okay. And after 90 minutes, when I realized that, you
Yep.
had to kill it and like restart it. So make sure you set your model checkpoint frequency to like something reasonable before you start training the policy.
Yep.
And there was another thing, right? Like, what was the other thing?
But I think whatever mistakes we made about training the model is reasonable given that we have never tried to do like training models during a hackathon.
Yeah, true,
We've probably
true.
fine-tuned ImageNet, and fine-tuning ImageNet was like what, 8 years ago?
Yeah, and it's kind of fast.
Yes, it's kind of fast, but that was 8 years ago. We probably
Yeah,
did it for a hackathon. Like, so doing this for a
but
new
lesson
hackathon.
learned.
Yes, lesson learned.
Lesson learned. Okay, what else? What else? What
Yep.
else did we do?
I mean, it was just, well, we did bunch of this, then we finally got it working.
Yeah,
And then we still had to deal with the burnt motor issue. So we couldn't let it like
yeah,
run for too long. So whatever you ended up seeing on the video, or video that you'll see later as well, was the best output that we got.
yeah. That was the best output that we got.
Yep. Yep.
We will probably play it now.
Yes, we'll probably play it now, or we already played it.
Yeah, we already played it. Yeah.
Yes.
Or we're talking over it too. Anything is
Yes.
possible.
Anything is possible. So that was one. That is one of the bits. But when we came into the hackathon, we honestly were not sure how we wanted to approach it.
Yeah,
We were rather, I would say I was overconfident that we would be done with this earlier, much earlier, and we
like
would,
always.
yes, and I would have time to work on hardware because I wanted to create a different type of gripper
Oh yeah.
that's a little bit more accurate, because we want to do something like origami with the
Oh,
arms.
I think it's really worth mentioning like the whole progression of the task we picked. We like started off thinking like, hey dude, let's grab a water bottle and make both the arms open
Yep.
it. And I'm like, we couldn't do it with teleop because we thought we could place the whole setup the other side, and instead
Yes.
of controlling it this way, we thought we could control it this way,
Yep.
which was
We
a bad idea, guys. Don't try it.
do not try
Extremely
it.
unintuitive.
Yes, we put it the opposite side
Yeah,
because Mr. Big Brain said it would be more intuitive.
we
Turns out
tried.
it's not.
We tried.
Yeah, because
This
you
one's for you. Don't try it.
do not try it. So we ended up setting up in a similar fashion to how it's set up right now,
The same direction.
and it just worked out better because we could control it more. Yeah, we could control it more.
The other thing, yeah, the progression of tasks, right? Like we tried opening a water bottle, not easy. Whoops. Since when?
I think last 10 seconds or so.
Okay. Yeah. So the thing was like we tried opening water bottles,
Yep.
seemed really hard.
The main problem with the water bottle was, well, there are
Finger
actually two.
size.
Yeah, the size is one. There are two more problems. One is,
Yeah.
uh the teleop config did not allow us to like effectively grip and like open the bottle cap.
Hmm.
So we changed it. Now it's better. Having it in the same side works.
Yeah.
The other issue is that the motor will very quickly overheat, especially with the
Yes.
type of bottles that we're working with.
Especially when you like give it like a lot of force, you have to hold weight, it
Yep.
like heats up.
As soon as you hold weight, I think we were holding like 300 grams.
Yeah, like half a bottle, like that's 250, 300 ml of
Yeah,
water.
there was 300 grams, and then we were holding thing for a while, and then we noticed that we also had a halt, similar halt, but it
Yeah.
was luckily at the end of the teleop.
Yeah.
Uh,
And just to note, the motor itself sends a signal telling that it's overheating.
yes, yeah, we were looking at the code, and we were running a script. We noticed that we would get like, hey, we couldn't write torque enabled or torque disabled
Because it
because,
was overheating.
yeah, because it was overheating. So that's great. If only we could like sort of restrict that even further, maybe on the motor's firmware level, uh,
Hmm.
for instance, or maybe it did, but then it too quickly overrated. I guess that's
Yeah,
it.
maybe like the one motor we had did not have the fail safe
Yes,
correctly, or the fail safe itself failed, or like not sure.
something
But
like that.
things happen when we do stuff in the real world, right?
Yep, like our fellow LeRobotters mention, or for like our fellow hackathon participants saw, when you use it or train it too much, it ends up overeating. Poof.
I keep doing this.
So,
Awesome.
so what's next, Sachin? What do you want to do with our two robot arms?
I really love the idea of coordination, right? Like that's one of the biggest like open questions. Like I think everybody in the community like is gonna try to explore soon.
Yep. Yep.
And just having like thinking of it like from the LLM land, right? Like
Yes.
you want something which is like generic enough to like adapt to any robot configuration, and that's what even like the LeRobot library philosophy is, right? Like they
Yes.
don't care what hardware you're using, this policy should just run. And
Yep. Yep.
we're trying to like explore stuff in that direction. And like the new JEPA model is like very exciting to me, and
Yes.
that's something I'm like
Yes.
dying to play with.
Yes. I mean, as long as we can get a bigger GPU or maybe get run pod set up, we are set. We
Let's run
can,
it on the cloud.
yes, run on the cloud. That's the only way you can do it. Uh,
That's it. Yeah, like what are you dreaming of, bro?
I I want to firstly the first thing I want to do is I want to create like a more higher accuracy, like higher. Forget about what I want to do is I want to create a high precision grip. Right now, the grip right now is not like something we can use for like folding paper. It's little difficult to fold paper and stuff with it.
Yep. Backstory: we originally thought we could build a bot that could do origami.
Yes, we wanted to do like
We
an
still
or
want to though. We
yeah,
still
which
want to
we
though.
still want to do.
We still want to do that.
We want to make like an origami service that you can like get personalized messages from, which are manufactured by the robot.
Build me a boat.
Yes, build me a boat.
Build
Yes,
me a
build.
boat.
Yep, and we mail it to you.
Literally.
Yep. The reason we wanted to do this was twofold. Firstly, because it lets you sort of do the hard bit of trying to fold paper. All the dynamics are associated with that.
Yes.
Robot collaboration there is hard, and I think that's something worth solving or building. And another thing that was interesting was packaging stuff.
Yeah. Like if you can fold paper well, you can gift wrap a box.
Yes, you can gift
You
out a
can
box.
package stuff. And like I think like that's like a lot of like a groundwork to fly off from.
Yep. And for such long horizon tasks, right? I don't think you can
Yeah.
sort of use RL. It wouldn't be that great at it. You need some type of planner and state evaluator.
Sure, sure, for sure.
Yep. Maybe HiSearl would be better for this. I'm not sure.
Experiment number X added to the list.
Yes, yes. So that's something we'll probably experiment with.
For sure.
That's that's what I've been thinking so far. Besides this, I think what's next for us as a team overall is we want to explore research,
For
im-
sure.
implement research papers. We hope that we can in the next year or so get at least one or two papers published in ICRA, IORs,
We're going
any
for it.
top robotics conference.
We're going for it.
Yep, you're going for.
All in.
Yep, because I feel robotics needs a lot more. Uh, like it's a lot. It needs a lot more researchers, honestly, in terms of people doing evaluating applications, figuring out way to do data sets, data creation, and like there's so many avenues to explore, and we need to be a part of it right now. It's like the early
It
stages.
is like totally unreal the amount of joy you get as a builder when you build a robot.
Yes.
And I'm like, I have not felt such a thing since the first time I entered a hackathon in the
Yes.
first year of engineering.
Yep.
And I'm like, such a joy is like, and the crazy thing is like, there are so many ups and downs when you build a robot, right?
Yes.
Like
Yes.
I was like devastated when I got your message, like the motor is cooked, and like we fucking
Yes.
made it back. we,
Yes.
we we found a way around it. That was like so fun. And like the and just again like reiterating like full circle, like
Yep.
marrying math, physics, electronics and comp science is like the most beautiful marriage out there. And like that's what like I love about like doing robotics
Yep.
now.
Yep. Like I said, when you build something and you actually see it
You
have
feel
physical
it, you
impact,
feel it.
yes, yes, that's when you know you built something really fun.
Yup. So I think it's dinner time.
Yeah, it's about dinner time. We should go eat something.
Yep.
Maybe we should get the robot to make it.
Hey, cook me a sandwich.
Next time. Next
Next
time.
time. Next time, guys.
Next time,
We're gonna
guys.
start the next one with the sandwich.
Yes, next time we bake a sandwich without onions.
But tomatoes.
Yes.
I love tomatoes in my sandwich.
Yes. A little bit of mayo.
Little bit.
Yes. Yes.
Ciao.
All right. See you, folks.
Bye bye.